Simplify the following expression to its simplest form. Consider x is equal to 2. To solve this question, we need to substitute in our given variable x is equal to 2, and then, using our order of operations, or PEMDAS, simplify it down until there are no more like terms we can combine, and that will give us our final answer. So let's start by doing that substitution. We have 2 times x, which is 2, plus 6y squared, plus x, which is 2, plus 2y, times x, which is 2, minus 3y. Starting with our parentheses, in this case, this is kind of mixing parentheses and multiplication because our two sets of parentheses are binomials being multiplied together, which means we need to follow the FOIL method to multiply them out. We actually do that in a different color. So we have front in our FOIL method, 2 times 2, which will give us 4. We have outer, 2 times negative 3y, which would give us negative 6y. Inner, 2y times 2 will give us plus 4y. And then at last, 2y times negative 3y would give us negative 6y squared. And now we simplify. We have negative 6y plus 4y would give us 4 minus 2y minus 6y squared. And now we can bring down everything else. We had 2 times 2 plus 6y squared plus 4, and so on. Next, we've done our parentheses. There are no exponents, so we need to now look at multiplication. We have one bit of multiplication here, 2 times 2, which will give us 4 plus 6y squared plus 4 minus 2y minus 6y squared. And then our next step would be doing addition and subtraction to finish out the simplification. So we're essentially combining like terms. Here we have a positive 6y squared and a negative 6y squared. These are going to fully cancel each other out. Otherwise, the only other like terms we could add or subtract is this 4 and this 4 here. Both are positive, so we'd add those two together and get 8 with our last remaining term that didn't have any like terms, minus 2y. Now, we just need to reorder our final answer in terms of greatest to least exponent, or greatest to least variable value. So we have negative 2y first, then the positive 8, and that is our final answer, making D the correct choice.